Okay, so in the previous episode, I went over how to pull down Docker images, how to run your containers, and how to customize them using the copy command and just overriding files with a volume. So this time I would like to do a more real world example. So how do you use this for development? How can you get the files to auto reload rather than building the images every time? And how do you tie multiple containers together so that they can communicate? So I'm going to spin up a quick little JavaScript front-end web application, nothing fancy, and a Python API. I'm going to have those two communicate together so you can kind of see how it all ties together. And so first thing I want to do, so as you can see, nothing's in here. You can use create React app. So if you look, npx is just an npm command that allows you to pull down templates. So I can say create React app Sontech web. And what that's going to do is go out, grab a template for a React.js front-end web application. It'll have your yarn lock files, your package JSON, and then a simple little React component so that you can see it actually working. And so what I want to do is actually customize this, have it call a Python API, and then tie it all together because as you saw in the previous episode, the Docker components don't expose anything by default, and then they cannot communicate with other containers by default. So if we put all this front end stuff into a Docker file, it's not going to be able to easily connect to the API by itself. So this is done running. So you can see it says yarn start. So that's how you would traditionally spin up. Oh, so we have to go into here. And if you look, it created the node modules, the source files, all that. And then you can just run it. And now what we want to do is remove that dependency for running these things locally. So if I go here, this is my React app. It says edit the app source file, save reload. But let's get it into Docker first because we don't want to be running these locally. We want these reproducible on all environments. So let's terminate that and let's create our Docker file. And as usual, we're going to start with the from. We can start with node here. And then what do we want to do? So let's look at our file system. This came with a package JSON and a yarn lock. And that's what declares what our dependencies are. So if we just wanted to copy everything up, we could say copy, copy. Let's create a workdir so that we're not inside root. So now with workdir, any command I run is going to be in /serve inside that container. So I'm copying every file from my local host up to the container. And that would work, except we don't want all of these files. For example, node modules. So if you look at the node modules, that's built on my Mac. We don't want that to actually copy up to the image. We want the image to build it itself so that it works in Linux rather than on a Mac. And the way you do that is the same way you would do it in Git or something like that. There's a Docker ignore file. And so we can just say, don't copy node modules up. So that when we say docker build, and then if we docker run, and we look, we've copied up the Docker file, the README, the package JSON, all the stuff that we would expect. So the next gotcha that you're going to have when you're working with Docker files and installing large packages is each of these layers are going to be cached. And if a previous layer changes, it'll rerun everything below it. So from node, workdir, copy, each of those are cache layers. So the next command we would want to do is install those dependencies because we didn't copy up the node modules. So if we say run yarn, that's going to install the packages. But since we've copied all of the files up, if we modify anything, if we modify text, the next line below it is going to get decached and it's going to rerun. So every time we change code, we'll have to reinstall our dependencies. We don't want to do that. And so what you really want to do is get anything that declares dependencies copied up first. And that's going to be your package.json and your yarn.lock. So let's copy those up. Let's run yarn and then copy everything else. And then give it a command. It's the command we already saw. Yarn start. And then we're exposing port 3000. So let's do that as well. So now if I run docker build and then docker, we should get a server on port 3000 after it installs all the dependencies and everything. So we're starting up. Oh, so we didn't expose it locally. So the other, the same thing we covered in episode 1. We want to expose local port 3000 to the containers port 3000. So now we'll be able to access the Yarn web application inside the container. We no longer have to have node modules locally. We can just run it and access it. So before, this was in the container, now it's locally. But as I said previously, let's create another one here, go IT temps, web. Let's shut this down. Start over here, docker run. So now that that's running, if I wanted to modify this, any code that I modify in here currently is not going to be reflected in that run. And the reason for that is we ran build, and that's a snapshot in time. How does the file system currently look? Let's build an image off of that. And then we ran that image. And so when we look over here, it's not going to modify. So let's say, right, if I change that, I'm not going to get that file. And the way we want to override that is the same way we did it with the Nginx config in the last episode, which is create a volume. So locally, we'll use a volume to overwrite some of the stuff that's put in the image. In production, we'll leave that snapshot in there. And so we're just going to say -v current working directory. If you're using bash, you'd put a $sign in front of this, or ZSH, both would. But I'm in fish, so you just do pwd, and then we're going to put it in that serve folder, that working directory that we defined. And now if I run this, this will allow me to edit locally and do development and reflect those changes within the container. So she's still starting up. My computer's not the fastest in the world, so just got to wait for it to go. So she's starting up now, so she'll load soon. All right, so now we have welcome to Suntex World. And so if I come back here and I modify and I just say hello moon, I can refresh and those changes are going to be reflected, because now it's no longer using those static files that were copied up in the image build, but it created a shared volume and reflected that on there. So now we have a JavaScript front-end React application running inside Docker. So then now the next thing we want to do is create an API. And so I'm going to use Poetry to spin up a Python application. There's a lot of different ways to do it, but we can just say Poetry new Suntex API and then go in there. It's not going to give you too much. It's a skeleton, but it uses this new PyProject.toml that allows you to declare your dependencies and everything that you would need. So to get this all running, the next thing is create a Docker file here. And same thing, if we want to say from, let's use Python 3.9. And then what do we want to do from there? We want to copy up the pyproject.toml because that's going to be what the dependencies are. And Poetry is not going to be installed in this container by default. So let's do a couple of tricks. Run pip install upgrade pip. That's just going to make sure that we have the latest dependency manager for Python. There's other ways to get Poetry. You can just curl it or wget it. But the Python image, it already comes with pip, so it's easy to just snag up Poetry right from there. Then from there, we want to copy pyproject.toml up because we want to install first. And then we'll we'll do the same thing. We'll copy all the files up. So that will give us our base Python Docker. So let's build that. Docker build. Make sure we didn't screw it up. Looks like it works. So if we want to run that, so we have our file. And one thing you're going to notice is that it generated a poetry.lock file, which we didn't have when we ran the node one, because we installed all those dependencies and generated our lock file remotely or locally, and then we copied them up. But we didn't install anything locally with Python. We just ran it all from the Docker. But we're going to want to get this file locally because if you look, once I exit, that file doesn't exist anymore. And so we can create a volume. So there's two ways you can really get it. So we could Docker PS. So if we run this, run, and then we check Docker PS, you can see I've got Sontech API up there. So I could copy that over. So I could say Docker copy Sontech API, get it out of serve, and then poetry.lock, and then copy it locally. But we need to add some additional dependencies anyways onto this because we want to have a web framework like Fast API. We want to have a web server like UVcorn. So one of the easiest ways to grab that file is to create a volume again. And so if we say create a volume, working directory, and make that into serve, put these arguments in the wrong order. So let's make sure that we get the Sontech API in there. So now that we have this, we want to add a few dependencies. So we want Fast API, which will be the web framework we use, and UVcorn, which will be the web server we use. So add all those up. And since we created that volume, when Poetry adds the dependencies and modifies that poetry.lock file, it's actually going to be created locally as well. And so now, if I exit this and check, I have the poetry.lock file. And so one thing that we're going to want to do is copy up that poetry.lock file too, because it declares the actual versions of the dependencies that we're going to install. So we want to make sure that's part of our dependency tree when we're copying these layers up. Okay, so that's basically it. Now we just need to set up our web server. So if and I don't remember the command, so we're just going to come over to Fast API, read their docs real quick. All right, so they have a simple example. You just import Fast API, import the CORS middleware, and then declare your first API. So we're going to just start with their example, and then we can tweak it later if we want to. Okay, so now we just want to create the command for our Docker container. So we're going to use Poetry to run it, because Poetry, unlike pip or something like that, manages those virtual envs for you. It's like an npm where it creates the node modules and has all the dependencies in there. You don't have to create a virtual env yourself. So we want to say Poetry run Sontech API app. And the reason we're saying this, if you look, in Sontech API, we created a server.py file. And then we created a thing called app. So that's all we want to do, is we just want to run that app. And then this is going to expose port 8000 by default. So let's get rid of some of these. So that should give us our first server. And then one trick here is, by default, UVcorn, which is the web server that we're using, is going to be listening on 127.0.0.1. We just want it to listen on everything. So we're just going to say listen everywhere. So let's hope that I didn't screw that up, and we can run this. All right, so it can run it. We forgot to expose port 8000 so we can get it locally. So let's run this. Port 8000, 8000. So that's just saying route it directly from my local 8000 to the container 8000. And let's see if we can hit it. It says hello world. And if you check, by default, Fast API generates docs. All right, so we got docs. So now we have a Python API running, and we have a front end running. So now we want to tie those together. We want to call the backend. Oh, and so there's one thing here. Let's go back and let's edit the API. And it's not going to reflect the changes right now. So if you look, this is saying hello world. If I change this to say hello Sontech, so let's just hit it again. It's still saying hello world. And the reason for that is Python is interpreting all that code and putting it in memory when you launch the server. So one thing that you want to do when you're working with Python files is put some type of reloader. UVcorn has a reloader by default, but and most do. But there are reloader file watchers that will reload Python if you are not using one that has one by default. So we want to rebuild the API because we modified the Docker file, and then let's run it. So, we're already going to get the new code because I modified it and restarted it. But now, if I go back and I change this back to world, we should also see that reflected. Or not. Did I modify it? Let me see. So I rebuilt Sontech API. And let me see. So I do have the Docker file, and it's saying reload. And then let's run it. And it says started reload process. So now it says hello world. Let's go change it again to Sontech. Oh, so the same problem we discussed earlier. So that was my bad. I was moving a little too quickly. We're running this off of the static image, that snapshot, right? And when we want code to be reflected in the container, we need to override that snapshot. And so same thing we've been doing, just make another volume from the current directory and then the place that we're going to be running the code from. So now, because the reloader was reloading the code, but that code wasn't changing because I didn't have the volume. So now, it says Sontech, come back here, let's change it to world again. Boom. Now in development, we're able to, in real time, modify these Python files and get the updated API changes. So let's tie these together. So go back to the web. And then let's call the API. So with React, you just use effect to call APIs once when the module loads. So we can just say import use state. I like to do them in alphabetical order. Use effect, use state from React. So that'll allow us to use hooks to spin this up. So first thing we want to do is const message, set message equals use state. And then we'll say hello moon. So hello moon is going to be our static message. If we don't have a API call, we'll have a default. And so you can see how that works. If I delete that and I just say show me message. And then we come back here to this app. And we reload it. We're going to see that it's still going to say hello moon. If that was the, yeah. So it's still going to say hello moon, but now it's coming out of the React state rather than out of a static string that was put in here. So now we can say use effect. Oh, now we need our dependencies, no dependencies for now. And then just use standard fetch. So we were listening on port 8000. So let's just call that. And then okay, so now we got the response, then we need to get the data. And then we should be able to just set that message from the data. So if we do that, we should now have hello world inside here using the API versus not. So let's go check it out. All right, so we are not getting it. It's saying hello moon. And the reason is because of CORS, the cross-origin request. So the server said, I don't accept requests from port 3000. I only accept them from 8000. So this client side cannot call me. And so there's a few ways you can fix this. The simple and dirty way, just tell the server to accept more hosts. So if we go back here, you can see it's saying localhost and localhost 8000. So let's just allow 3000 as well. So there you go. Now you can see we're getting a request. It's an AJAX request. And it says hello world, so we're updating that. So now we're communicating with the API from the React client. But adding all these hosts is not great. What you really want to do is put a reverse proxy in front of all of this and then have it routed together. And so the way you can do that is with Nginx. So we go to here, we can make a new directory called Nginx. And then do the same thing we did in the first episode. Let's create a new Nginx container that controls all of our stuff. And so if we run this, I don't think there's anything that we need. So we're going to want to grab the Nginx conf that is created and customize that to do our proxying. So if we do docker build Nginx, docker run, all right, so if you look here, it has a comp file that we can use to base ours off of. And so the way we would do that is using docker cp. So if you look at the docker ps, we have Sontech Nginx, and its name is Sleepy Booth. So if we want to copy a file out of that container, and we want to be in the Nginx folder. So Sleepy Booth, docker copy from Sleepy Booth out of the folder etc Nginx, was it, let's go back, etc Nginx confd, and we just want to copy that to here. So if we look, now we have this default conf. So now we can start making our own Nginx config that has everything we want out of it. So what we want to do is send anything that comes to the root over to the React app. So let's send all of that to Sontech Web 3000. And then for the API, let's copy anything that's /API over to Sontech API 8000. And then update the Docker file. Now we want to copy default.conf to etc Nginx confd. So that's going to put our new config in there and run it. So now if we do docker build Sontech Nginx and then docker run, that should load Nginx. And you're going to see it can't find Sontech API. It doesn't know how to communicate with other containers. And so that's where the fun comes in. So now we want to start having all of these containers communicate together. And the way you do that is with network. So you can say create secret network. So now that we have a secret network, we can come back to the front end and we can say, we want to name you Sontech Web and we want you on the network secret. And then same thing over here on the API. Let's name you Sontech API and put you on the network secret. So now those are starting up. They're going to be on that network. So let's try to run, and we also want Nginx on the network of secret. And now you see it can launch. And I forgot to tell it to expose its API ports, but send 80 to 80. So now, instead of going to localhost 3000, I should just be able to go to localhost. Once the front end is done running, we'll be able to go to localhost. We'll be able to see that we do have a React app being served up from Nginx. And this isn't how you would do it in production. This is just how you would do it in development. So there we go, localhost, and it says hello world, which means we are actually communicating with the server. But if you remember how we coded this up, it says localhost 8000. We don't want that anymore. Now we want to call API. And let's inspect that network, make sure it does what we want it to do. There we go. And it's saying 404. So we called localhost API, but it's getting a 404. So let's look at why. It's getting that Nginx request of /API. And the reason that's happening is because if you don't put a URL when you proxy pass, it'll just pass whatever is on Nginx. So /API, it's going to pass it. But if you put a / on there or another route, it will actually do it correctly. So now, if we do rebuild our Docker, and then run it, now we're getting a 200. Now we can communicate with the API as well. And so all of this was a complicated way to show you how to do a very simple thing, because Docker has all of this built in. So now that we have a front end, a back end, and Nginx, a proxy server, all communicating together, we can stop running each of these individually. So shut down the front end, shut down the back end, shut down Nginx. And so the correct way to do this, if you want to run many services together that are named and can communicate with each other, is you want to use Docker Compose. That's really the value. It's an orchestration framework. It does all that orchestration we just did. And the way you do it is by declaring your services. So you can say Sontech Web comes from the Sontech Web image that we built. And these images are from here. If you say Docker images, we have a, let's do Docker image prune. All right, so these are images that we created so far today. Sontech Engine, Nginx, API, Web. So we can just tell this, create Sontech Web out of that image. Create Sontech API out of the Sontech API image. And then the last one, Nginx. And then you can expose ports here. You know how we were doing the -p to expose ports? You can say that here too. From 80 to 80. So now this just launched the front end, the back end, and Nginx all together. And if we sit here and wait long enough, it'll be ready. So now we come back. And so you see, this is saying edit source app.js. We haven't rebuilt our Nginx. Oh, I'm about to lose my battery. No wonder my computer's been running slow. I've been plugged in this whole time. All right, so we never rebuilt our image. So let's go to the front end, Docker build, run it. There you go. No, she's still spinning up, so we got to wait a little bit of time. But like we did with our Docker run commands, you don't want to have to depend on rebuilding to get the latest code. What you really want to do is use volumes. And so you can use volumes inside this Docker Compose file as well. So you can just say, So before I was using the current working directory, right? Because I was in the Sontech web folder or the Sontech API folder. So now we want to go into that folder. Same thing here. Says we can't connect. So let's look at why we cannot connect. So I saw an error spin by while this was launching. Let's see, we're creating Sontech API. There we go. Upstream Sontech API cannot be found. So let's look at why. Sontech API. Yeah, that's all good. So we should be able to run that. There we go. Bad gateway, so that just means front end still spinning up. So we gotta give it a little bit of time to get that all running. And so you can actually use a dependency tree as well. So you can tell Nginx, oh, it isn't. It says connection refused while connecting to upstream client. So it can't connect. There we go. So my computer's just running slow, and so it hadn't even got to that point yet. So what I was saying, let's not even wait for that. All right, so what you want is depends on Sontech web, right? So now Nginx won't go until web is up. Okay, so, and then this makes sense. It's an array. So we can say this depends on both. So now Sontech Web and Sontech API have to spin up before Nginx will spin up. That way we can make sure that these are all running. All right, and now we have all of it working through Nginx with Docker Compose. So now you're just running one command, Docker Compose up. You kill it, kills all of them. And so this is a great way to work in development because you can have it spin up your cache server like Redis or Memcache, your database, Postgres or MySQL, all your APIs, especially if you're doing microservices. And then when you go to production, when you're small, before you're doing multiple servers, you can also just Docker Compose and spin everything up. And so that's all I want to show today. Just wanted to show you how you would work in development. But in my next video, I am going to go over how you would modify this for production. So for example, on the front end, we are running a development server, on port 3000, but it's just static, it's React. So what we really should be doing is yarn build, getting static assets, copying those over to Nginx, and then running Nginx serving up static files instead, because then we don't have to wait for a server to load. So in the next video, we'll go over production, how to make images that work in production, how to deploy them into production using either Docker Compose or something like Kubernetes or Docker Swarm. Hacking on containers in my tech merge, Python, Vim, and Nginx.